Hello everyone. In this video I will show you a very classic problem. It's a trivial problem, but will show you the power of hash table for lookups, which will turn a brute force solution into something linear, and we'll see how. The problem we have today is called two-sum. You will have a list of numbers and a target, and what will you need to do is to find the two numbers in this list that their sum is the target. For example, in this list 2 and 7, their sum is 9, so the output will be indices of 2 and the indices of 7. It could be very easy to do it with a brute force solution, which would be quadratic, and I will show you the solution for the brute force solution, which is the quadratic, but we need to find something else that is linear. This way you can understand why hash map is very important. Okay, let's start with the brute force solution, which is the bad, but let's do it. The brute force solution would be two loops. You will start from here and then go if 2 and 11 equal 9, no, so then you go to 15, then you go to 7. If not, you will go to the next one from 11 to 15 and from 11 to 7 and so on until you find a two number that their sum equal to the target. So let's implement this solution and then analyze it and see how we can do better. It will be very easy. It will be two loops on the list and that's it. Okay, let's do it. For I in range len of the numbers. Okay, for the second loop I wanted to do something different. If the first loop started from here, the second loop should be started from the next number. So let's do it. For j in range len of nums, but I will always want to start from I plus 1. And now it's easy. I wanted to check if the two numbers equal the target. If yes, I will return their indices. So let's do it. So if nums of index I plus nums with index j equal target, then return their indices I and j. Okay, so it's a typo. Okay, so we passed, but now if we submit the solution, we'll see analysis of our code. I am here and the best solution is here, which we are very bad. So we need something more better. We need to improve this solution. So this solution is quadratic because it's n and this is also n, so it's quadratic. We need something linear. How we can do it? Instead of doing two loops, we can use something more smart using hash table. We will depend on that hash table lookups is constant, so we will use this trick and we will do the following. If 9 minus 2 is which is 7 is in the dictionary, so we will return it. If not, we will store it, and that's it. So 9 plus 2 is 7, and 7 is not in the dictionary, so we will store 2 with its index, which is 0. Or if you want, you could store 1. The same thing, 9 minus 11 is not in the the dictionary, so our hash map, call it whatever you want. So we'll store 11 with its index. The same thing with 15, not found. Their minus is not in the dictionary, so we will put in 15 until we go to 7. 9 minus 7 is 2, and 2 is in the dictionary, so we will take 7 and 2. That's our solution, and we loop only one time. I hope it's clear. I don't know if you understand me or no, but that's how we do it. Okay, so let's start our problem. You can read the problem if you want, but I will directly start it, and here is it. You can use a Python dictionary, but I will use the library implementation for hash table, just for practice and knowing hash table in your brain, how does it work. If you don't understand this hash map, you can only use a dictionary, but this hash map make you play around it. You can use different hashing, different techniques, different strategies like chaining, linear. You can change hash function. You can implement your own hash function. You can change the table size, and you always see the load factor, so you can play a lot with hash table and learn it more in your mind. Today we only use it to know how is it important. Okay, so let's start by declaring a hash table. Let's call it ht, and this hash table will come from this class. Remember, we don't use Python dictionary. We could just do this, but I will not do it. So let's do hash table, and think with me. The size of the table, it could be the size of the numbers we need to store, but let's think as we are architect, and let's make it more bigger, so we have more lower load factor. You can disagree with me, do whatever you think it's more correct. So let's make m equal the length of the list of nums plus I will double it and plus 1. So my strategy will be very simple, and it will be linear, and that's it. We have now hash table. The second thing we need to do is to implement what we talked about. Remember, I only need a one loop with index and the number. We can do this easily with enumerate in Python. You can also achieve it using another normal loop, but I will use enumerate. So for I in num nums, it's I and value. Okay, but let's call it num in nums. It will be more better name. So the first thing I need to do is to calculate the complement, which is a minus. So complement equal the target minus num. This number minus this number, and this number minus this number. Now we need to search if it in the hash table or not. So we'll need to write a variable or a flag, call it whatever you want. So hash table, we need to search. Normally you could do something like this in Python, but my implementation, I just for hash table I just wanted to call it search. So I will search if the complement in the hash table or not. If I found it, I will return it and with indices. If I didn't found it, so I need to put the num in the dictionary and so on. So if found is not none, turn list of found and I. But this problem asks for a table instead of list. If I didn't find it, I will just put the num in the hash table. So ht.insert and I will put num. Else, so I need to return none. There is no two numbers that their sum equal to target. So if I didn't make any mistake, this code should pass all the tests. But I don't saw anything, so I always do a mistake. Okay, I did a mistake. Let's fix it. So the problem here is that I should always store in hash map two things, key and value, which the key is num and is the value is index. So this should be like this. And let's test it again. And I passed. We need to make sure that our solution is linear. So the first thing, we should go to the loop. So we have only one loop, which is linear. So everything here is linear. But there is a function here, it's called search, and another function here is called insert. So it could not be a linear, but hash table, search, and insert is constant. So we don't care about it. So the only thing we care about it is this. So the final answer is linear. So we could do it in a linear way. And this way I show you how using hash table for caching the answer turned a quadratic solution into a linear solution, which very impact our performance a lot. So that's it. I hope it was easy, but it's difficult. It's difficult when you do it in linear, but I hope you enjoy it. Thank you. Bye.